And the final page, and this first problem is kind of a doozy, but we'll get through it. It says tennis balls come, this is a great problem though because it's really kind of real life. It says tennis balls come 3 to a can. So I'm going to draw a cylinder because that's the shape of our tennis ball can. And I'm going to draw 3 tennis balls inside. So the inner diameter of the can is 7 centimeters, which means basically it's saying the diameter of the cylinder is 7 centimeters. And the height of the cylinder is 20 centimeters. Okay, the diameter of each tennis ball is only 6 though, so notice they don't go all the way to the edge. There's some space there. And you want to know what's the volume. Oops, the diameter is 6, excuse me. And the diameter is 7, I apologize. Okay, it says they want to find what volume is not occupied by the tennis balls. So, step 1, find the volume of the cylinder. Pretty easy. If the diameter is 7, the radius is 3.5. So the volume, or this area of my base is going to be 3.5 squared pi. And that's my big B times my height. The height of the cylinder is 20. So 3.5 squared times pi times the height, which is 20. The volume of my cylinder is approximately 769.3. So that is the volume of the cylinder. Okay. Now I'm going to find the volume of each one of the tennis balls. I'm just going to find the volume of one first. So if the diameter is 6, that means the radius is 3. They're in the shape of a sphere, so it's going to be 4 pi r cubed divided by 3. Our radius is 3, so I plugged it in. Divided by 3 times by pi. And I get 113.04 per tennis ball. So I have 3 tennis balls. So I'm going to multiply that by 3. So the total for tennis balls equals 339.12. So this is the whole cylinder. This is the tennis balls. I'm trying to find the blank space, so I'm going to take away the tennis balls and see what I'm left with. And I'm left with 430.18, which is in centimeters cubed. And if you notice, my answer says 137 pi. I'm just going to double check. That's 430.18. So I left mine in pi when I originally did it, but now I just left it. Right now we get to our last section, which is conversions. It says convert the following, and you're going to need to use your notes for this. Again, if I give you this in a test, I'll say like 1 inch equals 2.54 centimeters. So I'm just going to do the proportions off to the side here. So I'm going to do A over here. I know that 1 inch is 2.54 centimeters. I want to find out how many inches are in 12 centimeters. So there's my proportion. And when I cross multiply, I should get 4.72 for my answer. Now I get to a little bit trickier one. It's going from feet squared to yards squared. So I know that 1 foot, I know that there's 1 yard per 3 feet. But I'm in square feet and square yards, so I need to square those. So I know that there's 1 yard squared per 9 feet squared. So my proportion is going to look like this. 1 yard squared over 9 feet squared. I don't know how many square yards are in 10 square feet, so I'm going to have x yards squared over 10 feet squared. And when you cross multiply, you should get 1.1 yards. Okay, letter B is going from centimeters cubed to meters cubed. So you should say I have 1 meter and there are 100 centimeters. But I'm in cubes, so I need to cube it. So 1 meter cubed is 100 cubed centimeters, which is going to be, I believe it's 100,000, or 1 million. Okay. I'm going to now use that proportion. So 1 meter cubed is 1 million centimeters cubed. I'm going to set that equal to x over 78, When you cross multiply, you should get 0.00078. Right, and the last one is a typo. This should be centimeters squared. So I'm going to say that there's 1 meter for 100 centimeters. In this case, I just need to square it. So 1 meter squared is equal to 10,000 centimeters squared. Use that proportion now to set it up. So I'm looking for how many centimeters are in 4 meters squared. So meters goes on top because that's where it is on the other side, over x centimeters squared. When you cross multiply, you should get 40,000. Right, number 18 has to do with that measurement error again, like number 4 on the front side, I think. So the cube has a side that measures 5.7 when rounded to the nearest tenth of a centimeter. What is the range of possible values the volume could be? So I'm going to draw a cube here. This side was 5.7. Remember, all the sides are equal on the cube. So the range of possible values is 5.65 to 5.75. So ultimately, to get that, I would do 5.65 cubed, because that would give me the volume, because you would do 5.65 times 5.65 times 5.65, base times height times width. Well, all of the sides on the cube are equal, so really it's doing 5.65 cubed. And I get my biggest value is 5.75 cubed. Again, it's length times width times height for a cube. They're all the same, so you can just cube it. And that should give me 180.36 and 190.111. Again, it can't be equal to this last one because 5.75 would actually round up. All right, number 19, it says the area of Long Lake is 0.10 square miles. So again, this goes back to knowing, looking at your notes, 1 mile is equal to 1.61 kilometers. Right, and I'm in miles squared, so I need to make sure that my ratio is squared. So 1 mile squared is equal to 2.5, let's check, 2.59 kilometers squared. Okay, I'm trying to find out how many square kilometers are equal to 0.1 miles squared. So I'm going to have 0.1 over x. When I cross multiply, I should get 25.92 kilometers squared. And the last one is very similar, except now I'm going from square kilometers to miles. So it tells me 1 kilometer is equal to 0.62 miles. I need to square it though because I'm trying to find square miles. So 1 kilometer squared is equal to 0.62 squared, 0.3844 miles squared. I'm going to set that equal to 9,827,000 square kilometers and figure out how many miles squared that is. So when I cross multiply, I should get 3,794,208.5. All right, I apologize if this was fast and there were some technical difficulties, but I did get it done. Come in with questions tomorrow if you have them. Hope this helps you out.